G'day folks, in this video I'm turning the part in pink. The drilling will be done by someone else. The red arrows in the middle of the picture show you the distance the parting tool still has to move towards the chuck, and you can see the tap and the drill will both be hitting things. The tap will be into the chuck and the drill will be into the headstock. This is drilling a hole with a drill that I've just sharpened. Not very well. Instead of cutting 11.5, it's cutting 11.8. The two rings you can see at the bottom of this hole show just how imperfectly I've sharpened the drill. So I thought I'd try a slot drill in the turret and use it to drill the hole and then bore it out to the right size, but it just wasn't rigid enough in the turret. So I thought I'd do a setup where I use the slotting drill in the gang block, where it would be nice and rigid. I apologise for these invisible tools. I didn't realise it obviously when I set the camera up. So I decided that I'd just, each cycle I'd put the slot drill into the gang block using stops in the program. But I realised that I had no register for the position of the cutting edges on the slot drill, so the hole size could vary all over the place. So I decided to completely change the program. Use a drill of 11 diameter to start the program off, and then open it out later with a boring bar in the turret. And I thought by separating the drill and the tap with the boring process, I would make sure that I didn't confuse them and put the drill in when I should have put the tap in, etc, etc. Here the boring bar is opening up the bore to 11.6, which is what I wanted as the tapping drill size. The program stops for me to put the tap into the gang block, and I have to put the spring on the back end of it and put the locking pin in place, so it takes a little while. I'm only making 10 of these parts in total, so it really not too much of a drama. I changed the program to chamfer here after the threading because I noticed even though it's only 32 TPI, I was getting a slight burr thrown up by the threading tool when it was previously chamfered. Right, let's make some chips. I just noticed this is my 19th narration clip and I'm only halfway through the video so far. Okay, so this is the 11mm drill fitted to the gang block and it's drilling away the material. Now the program stops while I take the drill out of the gang block. Here I'm using a little 3D printed T handle for the hex wrench. Really works well. So now I push the magic button and the program starts again. Oh, we've got an invisible tool again. At least you can see the material disappearing. That was just a 55-degree turning tool. And this is a full profile 32 ME thread insert. You can't see the insert, but it's there because you can see the thread being cut. That was at 1600 RPM. Now we've got this tiny boring bar. Just putting a bit of a chamfer on the start of the thread and taking the hole out to 11.6. which is the size I wanted to use as my tapping drill size. There's the boring bar's disappeared. Stop program again. Have to put the tap into the gang block. Fit the spring and the washer and the locking pin. A dab of jungle juice. 1000 RPM. I haven't got the feed set right. It's not feed. The tap's not coming out enough. from the floating tap. It's sort of, I just got to slow it down more, that's all. The parting tool's putting a chamfer on and facing the part. Then puts a small chamfer on the back and parts the part off. And there you can see the part mid-flight before it hits the floor. This is in aluminium. Please pretend it's in brass, because it will be in brass. I just don't have enough brass material for a lot of messing around getting the program right. This has been a long video for me, so if you're still here, thank you for watching.